Good day everybody. This video is to demonstrate how to do clustering, time series clustering or spatial temporal clustering to be more accurate. We have here the data set. This data set was transformed into Cartesian data set, which mean x value and y value. X value will represent time and y value will represent the O3 level, ozone level. So each point here, let's close it first. Sorry. Save and open it again just in case. Okay, so each point here represent space and time. The space is nili and the time is 1 hour 1 day 1 month 1 year 2005, and the last point is Shah Alam space and time is hour 24 day 31 month December and the year 2012. Each point of time occurs many times in each space. What I'm trying to say, in Putrajaya, when we have hour 1, we also have it the same, hour 1 in Nilai. The time is equal in all the space. So point 1 here, point 1 which equal to hour 1, day 1, month 1, year 2000 y or 2005, this point 1 also occurred in another space, in another station. Let's say here we want to go to number 1 again. Let's just rearrange it to make it more clear. And here we go. So point 1 in time happen in each station. In Nilai we have this date. In Shiraz we also have the same date. In Tangun Malam we have the same date. So point 1 in time have various ozone level. So now we have some time series. Point 2 in time have various ozone level, and point 3 and so on. The first point in time is 1/1/1/2005. The last point in time is 24/31/12/2012. This is the last point of time. 68 you can't even read that big number, 96,816. So we have the Cartesian, the time as x because it's longer, and y as ozone because the value is range from, let's say, the range of from 001 till 0181. And let's revert the data back as it was and do some clustering. Don't save. We open Wika. Wika will take some time to load. By the way, my computer specs are i5 3.4 gigahertz, fourth generation. That's quite decent, and 12 gigabit of RAM. So now we have Wika. We open the dataset, that file, CSV file, this one. No need to do any kind of pre-processing. The data is already pre-processed and transformed. We go to clustering. We choose our clustering method, the required one. Let's have some, let's say 30 clusters, 40, just to show some, and increase this one to have some better. Okay, and one last thing, do not forget this one. We need to ignore the space-time attribute. We need to cluster x and y only. So we ignore this one and start. It will take roughly around 2 minutes only, less than 2 minutes to perform the clustering based on the criteria I selected. Let's wait for it. Wika is digging for knowledge, looking left and right, right and left. Mr. Wika. I'll be back soon as Wika is done digging. guys, still doing some serious digging and not yet complete. Come on, Mr. Okay, week is done. Now we have 30 clusters or 40 clusters. I select, I don't remember. And we have k-means here. Let's visualize. So, what does this clustering means? Here we can't understand anything. So x will be x and y will be y, and here we go. So what does this mean? We have from time point 1 to time point this last point, we have all the ozone level. So when time was 1, the ozone was here. We have very high ozone concentration in this area. This okay, plot, no problem. This is cluster 2 and this is cluster, here we can 27. So let's continue here. Here we have high concentration of ozone, and we have middle, let's say, concentration of ozone, and we have average, let's say, and below average. It can be categorized in whatever way. So in this, let's say, let's take a look at this gray one. Gray one is cluster number 9. Cluster number 9 is the very high concentration of ozone, and also cluster number 3. 9 and 3 are very high concentration. 9 and 3 happen in all stations. Let's take a look at the space-time distribution. This is space-time. It looks nasty, but what does it mean? Here is the first station, green, gray and blue. This is the first station here, all this area here. I'm moving the mouse. This is Nilai station. The next station was Shiraz. This is Shiraz station. Shiraz have the highest concentration among all the other stations here. It's clear. After Shiraz, we had what station we had after Shiraz? Let's take a look. Let's speak. No cheating in exam. We had Nilai. After Nilai, we have Shiraz. Here I'm reading the name. And after Shiraz, we have Tangun Malam. We have Battling Jaya, and so on. So we have in each space the distribution in each in the 40 clusters that was chosen. We have 40 or 30 clusters. So we can do analysis like this, and we can better understand the clusters and the stations. It's clear by eye what is going on here. Let's go back to X. So we have high, we have low, we have medium, and like this in each point of time. We can increase, we can redo the clustering. Let's give it another run, see how it will look like. With, let's say we want 20 clusters. Let's do a 5. Start. It will take another 2 minutes. That was 5 seconds, not 2 minutes. So let's visualize it again. Here we have some clusters, x to the x and y to the y, and we have here this cluster number 4. Cluster number 3 is the high. So we can say it's view. We need to increase the number of clusters, but if we go space and time, so on, as you can see, it's clear. 1 2 3 4 5 for the first station, 1 2 3 4 5 to the next station, and so on. We can try different number of k. It's running fast, and we even can do some other clustering technique. And thank you for listening. I hope this video was educational.